Alright, so this is a volume of a pyramid problem. And do you know the relationship between the volume of a pyramid and the volume of a prism? So this is
Pyramids, you have to divide the side lengths by 2.
no.
What?
Pyramid, prism. So first of all, let's talk about volume again. So remember we said pretend this is a vase with a flower inside, right? And what's the first thing you do when you fill it up with water? Does the water go up the side of the wall like that?
Nope.
What does it do?
Goes on the bottom and spreads out evenly.
Spreads out evenly. So to figure out the volume of a prism, first you gotta take care of the what?
The base area.
So, yeah, so volume equals the base area, just like that water covers the base area. Then the water does what after it covers all this base area?
It starts going up.
Goes up the height. Right? So the volume of a prism and a cylinder, the formula would be base area times height. You with me? So in this case, I didn't put this height right here before 4 millimeters. So in this case, right, it'd be 5 times 3. That's your base area, right? Length times width times what?
Height.
Which is what number?
4.
4. Okay. And what is 5 times 3 times 4?
60.
60. And then millimeters what?
Squared. No, cubed.
Cubed. Okay. So that's the volume of a prism, right?
Yeah.
Okay. The thing to me that I think is really, really weird is that if this was like filled up with water, or like let's just say sand. So let's say you had this pyramid, and let's say you filled this pyramid up completely up with sand, and you poured that sand into this prism. You notice how they have the same exact like length and width? You see those values? Yeah. Same, right? Same right there.
Base.
Same right there. Same base area, right? And same height. I call this the Indiana Jones height. It's like he drops a rope down and climbs down the pyramid like that. So it has the same height. This height is 4. This height's also 4, right? Mm-hmm. All right, guess how many times you have to actually like fill this up with sand and pour it into here. How many times do you actually have to do that to fill this entire prism? How many times did you have to do that? How many times do you have to fill up that pyramid?
Twice.
3 times.
3 times?
Yep. So and it's kind of weird, right? Because it doesn't look like this is triple the size. Yeah. If this pyramid were to fit inside of it, you know, it would be like, if that pyramid would fit inside the prism, the height is the same, it kind of goes like that. Well, all those side rooms, all the room around it is the same size as 2 more pyramids. So if you fill it up, if you put sand in this thing, and like you fill this thing up with sand on the left, it's only and you pour it into the prism. The first time you do it is that. The second time you do it, it's that. Third time you do it, it's that. It takes 3 times. Okay? So that means that the formula for a pyramid is 1/3 base area times height. That's the formula for a pyramid.
Okay.
1/3 base area times height. It doesn't even matter if it's a different kind of pyramid.
So 5
it could
times 4 basically.
So in this case, so the volume in this case would be 1/3, and the base area is 5 times 3, and then the height is 4, right? So 5 times 3 is 15. So 1/3 times 15 times 4. And you can do this different ways. You could do just 15 times 4, which is what?
60.
Which is what we got here, right? And then times 1/3, which means divided by 3.
20.
20. So the answer is 20.
Yeah.
Or you could do it these two first. So that's the same thing as like you can put a little 1 right there, and that's 15 over 3, which is 5. Right. So if you go across the top and across the bottom, 1 times, oh, that's so big. 1 times 15 is 15. Then 3 times 1 is 3, and that's 15 over 3, which is 5. And then what's 5? Because all of this is 5. It's 5 times 4.
5 times 4. 20.
20. So what are the two ways to do it? There's actually
5
three
times
ways.
4, and just multiply it all and divide by 3.
Right, and how'd you get the 5? When you said 5 times 4, how'd you get the 5?
Because it's the length.
No, like, you said 5 times 4, right? Where'd that 5 come from?
The base?
No. So it's...
Give 15?
It came from the 15. How?
Because you divide 15 by 3.
Yeah, 15 divided by 3 is 5. Then that's 5 times 4. Okay, so this equals 60 millimeters cubed. Look, even if you have a hexagonal prism, so if you have, or no, like let's do a triangular prism. So you do this, like that. Look, let's say you have that, 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 that. What do you call this shape? It's an ugly shape, but I mean, I'm making it ugly. It's not really ugly. And that's called. Oh man, I think I could do a better job with that drawing. What is it? What is this drawing?
Triangular. Not
there.
Pyramid. It's a.
Do you see how it has two bases that are parallel?
Yeah.
So you have this base here that's parallel to this base here. If you have two bases that are parallel, it's a prism.
Oh, prism.
Right? Because this only has one base. It doesn't have another base. That's why it's a pyramid. These guys have two bases that are parallel. That has that base and that base. And actually, rectangular prisms have more than two parallel bases. It just depends how you look at it. Right? So like this could be like this. Aren't those parallel?
Mm-hmm.
Those could be the bases if you want. Or these could be the bases. Maybe the ones in the front and the one in the back could be the bases. So anyway, what do you call this one down here? Just say the name of the shape of the base shape. What's the base shape?
Pyramid.
No, it's not. What's the base shape?
Oh, it's rectangle.
What's the base shape? What is the shape called?
Oh, triangle.
A triangle. And it has parallel bases. Things with parallel bases are called prisms.
Yeah, prism.
So it's a triangular prism.
God.
All right. So look, same formula as that. So volume equals fill up the bottom base area. Times what?
Height.
Height. Water goes up, right?
Yeah.
Base area times height. Okay. So let's say this. We know that this right here is, I don't know, 10. And let's say this right here is 8. And let's say this right here is 20. All right. So how do you find the volume of that guy?
Multiply. Do 8 times 10 times 20 divided by 3.
No.
No.
Because you don't have a pyramid. This is a prism. This is related to this shape.
Oh, so just don't divide by 3.
It's the base area times height. There's no divide by 3.
Base area times.
So what's the base area?
What's 200?
This shape right here is related to which one of these two above it? This one here is related to which one? The pyramid?
The prism.
The prism. Do you sometimes forget that this is called a pyramid?
No, I just forget about prism.
Prism, okay, yeah. Prism's a weird name. I get that. It kind of sounds like pyramid. But this is a prism. The way you know you have prisms, like it's because you have what? What's the defining characteristic of a prism? I'm gonna draw another one.
You do base area times height.
No, but what's the defining characteristic of a prism? What makes a prism called a prism?
Pyramid. And
What did you say?
because it's like a pyramid, sort of.
No.
No?
It has nothing to do with pyramid.
I have no clue.
Look. If you were on the video, you would hear it. You have this, and you have this. This is called a hexagonal prism. Why?
Because it's a hexagon.
Because it has parallel hexagon bases. Look, watch this. I predict you're about to say, "Whoa! Oh, I get it." Watch this. Guess what this is called?
A pyramid.
What kind of pyramid?
Hexagonal pyramid.
Hexagonal pyramid. What is this called?
Triangular pyramid.
What's that?
Triangular pyramid.
Triangular pyramid.
Daddy.
What is? Wait. Let me draw 5 sides. 5 sides, and parallel on top. Uglier.
Pentagonal.
Pentagonal.
Stop pyramid. Oh, prism.
Yeah, because it has
Pentagon.
no parallel.
Oh, parallel. Pentagon.
Not
Parallel pentagon.
bases.
Oh.
It has bases. Parallel bases. What that shape? This shape right here is called a pentagon, and this base is a pentagon.
Oh.
But they are parallel. They don't intersect. That's how many bases do pyramids have?
1.
Yeah, prisms have 2,
Oh.
and they're parallel. They're parallel. In fact, I can draw. Watch what I can draw. I can draw this right here. I can go like this. I can go like that.
That's the difference between cones and cylinders, also.
Yes, it is. And I can go like this. And by the way, the volume of a cone is 1/3 the volume of a cylinder. Go like this.
Wow.
And go like that. Go like that. Okay. And watch this. Watch this. Look at this.
What?
What's the name of that shape?
Triangular prism.
It is. It's the same exact shape as this one right here, except the bases are this way.
Oh.
See? So if I want to draw this exact one, I can just say no problem. I'm gonna go like this, and I'm gonna say, whoa. I'm gonna say this height right here is 8. Bam. And I'm gonna say that this right here is 10. Bam. And I'm going to say this over here is 20. And that is that. It's just laying down. All right, so how do you figure out the area of this, the volume of this triangular prism? It's, if you think about the vase being filled up with water.
So you 10 times 4 times 20.
Wait, what's
because you have the triangular side.
What did you just say?
Because you have the triangular side.
So because you figure out the area of a triangle. Like what is this area of this triangle?
Base times height times 1/2.
Yeah, it says 1/2 little base. Don't think of it as anything to do with that base area. Base times height. So 1/2 base, which is 10 times what?
8.
10 times 8. All right. So that's the volume of this area of that blue base right there. What is that area, by the way?
It is 80. Wait. 10 and 8? Oh, 40.
40. Okay, so, and then remember, it's times height, which is, the height is what in this problem, actually?
20.
20. So it's 40 times 20, which is
800.
800. And what's the unit going to be if this is in mummas?
Oh, millimeters.
Millimeters what? It's volume. Cubed. Okay. Do you get that?
Yeah.
I'm going to draw the exact same shape. I'm going to go over here, and I'm just going to make... Oh, by the way, that's the same exact volume as this guy.
Okay.
Do you see how that's the same volume?
Yeah.
It's the same shape. All right? Watch. Well, look at this. Look at this. See this shape right here? I'm going to copy it. I'm going to copy it. Go over here. Copy it. Copy. Over here. Paste. There it is. See it?
Yeah.
Okay. Now I'm going to erase. I'm going to erase that. And erase that. Erase that.
It's a triangle.
Everything. You can't read my mind.
Except for the triangle.
Except for triangle. And then I'm going to go right there. And then I'm going to draw
Pyramid.
a pyramid with the same height, the Indiana Jones height. And that height is what? What's the height?
20.
20. And this is, so this is 20. And this is 10. This is 8. I see 8. It's hiding right there. That's the height of the triangle. We can zoom in right here. Or zoom in cam. And we can see that it's, if we just dealing with that triangle, we got 10. We have 8. All right, so what is the volume of this pyramid, this triangular pyramid?
So.
Well, you do your work. Don't mind me what I'm gonna do over here. You do. You keep thinking about it over there, okay?
266.666666667.
266.67. Yeah, because the volume of this pyramid is just 1/3 the volume if it's Prism Buddy. Do you get that? It has the same base area. It has the same height. The only problem is it doesn't have 2 bases. There's 1 base. So it's got 1/3 the volume.
Oh.
1/3 base area times height. Do the long way.
Oh.
1/3 base area, that's base times height divided by 2. So now you got to go 1/2. And then base, which is 10, times your height. Height. Look, that's your base area. Look, that's base area. You're watching? Base area. Explain to me how that's base area.
Because it's
Explain to me how that's base area.
It's 10 times 8 because it's a triangle.
Mm-hmm.
It's split by half because triangles are half of a square.
Good. And then there's a 1/3 because pyramids have 1/3 the volume of prisms times the height. What is the height?
8.
What is the height?
Oh, 10.
10, not the height of the triangle. The height of the Indiana Jones height, the height of the pyramid. What is Indiana Jones height? When I say Indiana
20.
Jones height,
Wait, no.
what do I mean by?
Oh, it's 20, yeah.
But what do I mean when I say Indiana Jones height? Do you understand what that means?
Because he's climbing down the road.
Yeah, where's he climbing from?
The top.
The top of the what? Top
pyramid.
pyramid. All right. So if you punch this all out on a calculator, you're going to get 266.67 millimeters cubed. Do you get it?
Yeah.
All right. Do you want to connect it to cylinders? We can do it really fast if you want. We can even do cones if you want to. So pyramid, if I do a cylinder, watch this. Here's a cylinder. Bam, bam. Same exact formula. If you understand the vase. There's your R. Let's say R is 10. Right?
Yeah.
And I didn't even do, I don't think cones are on this test. Maybe they are. But let's just say they are. I'm going to draw it right there. I'm going to draw it right there. And I'm going to say right here is 10. And we'll say it's all like, we'll say it's centimeters throw you off. Centimeters. We'll say Indiana Jones height right here is 20. Height over here is 20. All right, what's the volume of each one? Better have our general formula first. What's our general formula?
Base times height.
That's not the formula.
Base area times height.
A volume equals base
area
times height. All right, and volume equals, well, how do you do that? What's the formula?
Base area times height.
What's the formula?
Base area times
Formula for the base area.
Oh, like I do it.
No, it's not. Are we dealing with rectangles here?
It is.
Wait, are you about to say like radius squared times pi? Because that is a pet peeve of mine. It goes in the other order.
Oh, I was going to say circumference times height.
Then it's just wrong.
Oh yeah, because you have to multiply by height.
No.
It is.
Nope. Look. It's.
Wait. Radius squared. No. Radius. No. It's pi radius squared.
Pi r squared.
Pi r squared.
Pi r squared. Pi radius squared. Pi
R
r squared. Hey, look. You have pi. You know this is a. You know, like what's if this is feet? Like if you have this rectangle and it's in feet, and this is 3 and this is 2. What's the area? It's in feet. So what would this area be?
6 feet.
6 feet what? Area.
Square.
Okay. So area involves square, right? So look, if you're thinking of the area of a circle, could it be this formula? Oops, not that. Could it be that formula? Or that formula? That formula? Or that formula?
To the right.
This formula right here?
Yeah.
Yes, because that has squared in it. That has squared.
Yeah.
Just like that unit up there.
Yeah.
That's how you can remember. This right here, that's your circumference formula. That's the area formula. What's this the formula for?
Circumference.
What's this the formula for?
Area.
Area. All right, so here we got base area, pi r squared times what?
Height.
What's the height?
20.
20, all right. We'll punch out the pi. So we'll do 3.14 times what?
10.
If you want to get it wrong.
What? No, times 20.
Still want to get it wrong.
So the second, no, square?
So 10 squared.
What?
10 squared.
10
Not-
squared?
10 is the radius.
Oh.
So it's 10 times 10.
Oh.
See, you got to go 10 times 10 because it's r squared times 20. You follow me?
Yep.
Okay, punch that on our calculator. I'll race you. Ready, set, go.
$6,280.
I say 6,280. Volume equals 6,280. What?
Cube. No. Cube, yeah.
What cube?
No, oh, feet. No. Centimeters. Cubed.
Centimeters cubed.
Yes.
All right. Now I'd like to do the volume of this cone. I could jump right to it if I want. I can do it with a calculator, click, and done. What would you?
Oh, divide by 3.
Yeah. You just get this area right here and go.
Oh,
And
wait.
go
29.33.
6280 divided by 3. What'd you get?
293.
Wait,
Oh,
2093.33.
Yes.
Right? 2093.33 what?
Centimeters squared. Cubed.
Which is it?
Cubed.
Cubed. All right. Any questions on that? Do you understand the connection between pyramids and prisms?
Yes.
What's the connection between pyramids and prisms?
For pyramids, you divide by 3. Instead of prisms, where you just multiply length times width times height, or base area times height.
base area times height, because you cannot do length times width times height with a triangular prism. Right?
Yeah.
All right.